kind of tricky. All right, students, so the second part of this, we're going to look at, move into the period changes. So just a couple of reminders on this. When you have a number in front of your trig function, that causes the amplitude to change. And the amplitude is measured this way. It's the half the distance between the crest of the waves. What we're going to look at today, though, in this part, is what happens when the period changes. And the period changes when b is not equal to 1. So if b is bigger than 1, something happens to the graph. And if b is between 0 and 1, something else happens to the graph. Okay, I'm going to open up this applet. There's a lot of this stuff on the internet that's really good. This is a Geogebra applet, and I really like Geogebra. They have really good applets available for students to look at and for teachers to use to teach concepts. So let's see. I'll load this up. So what we have on here is basically a trig function, and we're looking at y equals sine x. So I want to just remind you of what we learned. So if we change the number in front, that changes the amplitude. So right now I'm going to slide that up, and now the amplitude is 2. So when you have 2 sine x, the max was 2, the minimum was negative 2. As I continue to increase this, if I go up to like 3, amplitude's now 3. Come on, stop. It's hard to get this thing to stop. Okay, so the amplitude's 3 sine x. So we learned that. Also, if you shrink this, so if we go back to an amplitude of 1, which is here, okay, if we shrink that, like if you have a decimal like, say, 0.5, then notice the amplitude is shrinking on this. So here's 0.3 sine x, which means the max is 0.3 and the min's negative 0.3. We also looked at what happens when you have a negative. So when you start putting negatives, then this starts reflecting. So notice this is negative 3 sine x. So the maximum stretched to negative 3, but then it reflected over the x-axis. So that's what we learned so far. And that's kind of a nice little thing to show students. And that'll help you kind of see how that goes. But now we're going to look at what happens when the period changes. So I'm going to change the number in front of x. Okay, and I'm going to right now just do this. I'm going to slide this, and I'm going to move that number to 2. So if you graph the y equals sine of 2x, then the graph shrunk horizontally. So the period changes. The period now is 0 to pi, because there's 1, 2, 3, 4, 5 key points. And if I continue with this, if I change that to like a 3, y equals 3 sine x, well, the period has gone now from 0 to whatever that number is. Okay, so the idea is if this number right here gets bigger, then the period changes. The graph shrinks like this. So it just keeps shrinking and shrinking and shrinking as that number gets bigger and bigger. Okay, however, if you take it the other way, so I'm going to get back to kind of the beginning here. That's your standard sine wave where you have 1x. If I make this a fractional value, what do you think will happen? Okay, I'm starting to get decimals, so it's starting to stretch. All right, so that thing starts to stretch as you get into the decimals like that. All right, so again, what I'm trying to show you is if b gets bigger than 1, come on, stop where I want you to stop. There we go. Okay, if it gets bigger, the graph shrinks horizontally, but if the number in front gets smaller, then it starts to stretch. So that's what we're going to look at basically in this section, is how the period behaves. Okay, so a couple of things I want to introduce you to on here is, first of all, we know that the amplitude is the absolute value of A. The period gives you this formula, 2 pi over absolute value of B, right? And what we're going to do on this is B changes X values, and then A changes Y values by multiplying. So you want to understand the arithmetic, because if you understand the arithmetic, you'll ultimately understand what's going on in these problems better, I think. Okay, so I'm going to go down this example 1, and we're going to crunch these out in a certain way. You may not have enough room on your handout to write all this, but if you don't, that's okay. So we're going to start with looking at the y equals sine of x graph. So to begin with on our table, we're just going to use standard values, like we're going to use 0, pi over 2, pi, 3 pi over 2, and then 2 pi. And then do the negatives, negative pi over 2, negative 3 pi over 2, negative, whoops, I got that, kind of getting out of track here. Okay, so we'd have negative pi, then negative 3 pi over 2, then negative 2 pi. What I'm doing is just going around the unit circle by 90-degree increments, really. And remember, the sine is the y values. So on a unit circle, that thing just decided to spring a leak on me here. So let me erase that. Sometimes the OneNote just kind of has little bugs in it, and it just does funny things sometimes. Okay, it's always something unexpected. So what I was going to show you on this is the sine is the y value. So we're going to look at just these y values on the unit circle and crunch these out. So you would find the sine of 0 is 0, sine of 1 is 1, sine of pi is 0, sine of 3 pi over 2 is negative 1, and then sine of 2 pi is 0. That's what we learned in the first part of this section. And then if you go backwards with this, negative pi over 2, you would have negative 1, negative pi, you would have 0, and so forth. Okay, anytime you need to pause this video to get stuff written down and kind of think about what I'm saying, then please do that. So we got that. We're going to go ahead and graph that and get this set up. So let's go ahead and take the time to get the x values put on here. Always label that in radians. Okay, then do the negatives the same way. Okay, now the amplitude is going to be 1 on this, so we need to probably just go all the way up to 1 and then down to negative 1. So I think I've kind of got this set up like that, and that's all you need to put on the y-axis. Okay, now let's go ahead and plot these points from the table of values. So go ahead and get those put on. I'm just following the table. And this will take us through 2 periods like this. So again, these are your 5 key points that we're plotting on this. Oh, hold on. I'm doing this. I'm not doing that right. I just caught something on this. Okay, this is a 1. I got to be careful when I do this stuff. Okay, so we've got this. So we have 0, 1, pi, 0, then back to 1, back to 0, and so forth like that. So just plot the points and go ahead and get the basic sine wave done. This is what we learned in the first part of this section. Okay, and then I'll label that as y equals sine x. So what we're learning is what happens when the period changes. So on this one, that 2 is causing the period to change. So what we're going to do on this, we're going to fill this stuff out here. First of all, when we look at the amplitude of y equals sine x, of course, is 1. That's why we made the y go from negative 1 to 1. Now the period, we have to use this formula, and you want to write this down. This is 2 pi over absolute value of b. b in here is the 2. So we would have 2 pi over 2, so therefore the period is pi. So that means that every time pi goes by on the x-axis, you cycle through the 5 key points. Okay, the increment is very important. What you always do on the increment is you do the period divided by 4. So the period's now pi. Pi over 4 is what we call the increment of the x-axis. So instead of making our x's go by pi over 2's, we're going to make them go by pi over 4's. Okay, some of this stuff I'm going to kind of have to do at the side here a little bit. I'm going to shrink this unit circle and try to squeeze this in. You may not have to write all of this out, because if you understand what I'm doing, then that's fine. I'm just going to need to probably take up a little bit more room over at the side when I'm doing the next part that I want you to do. So what we're going to do is we're just going to count by pi over 4, starting with 0. So we're going to start with 0, then we go 1 pi over 4, 2 pi over 4, 3 pi over 4, and then we're going to stop at 4 pi over 4 because I'm going through 5 key points. So I've got 1, 2, 3, 4, 5 key points. And what we're going to do is, over at the side, we're going to do some number crunching. So we're going to do 5 key points. We're going to start with x equals 0. Then we're going to go to x equals pi over 4. Then we're going to go to x equals pi over 2. And again, I'm reducing these fractions, see? And then I'm going to go to x equals 3 pi over 4. And then finally, I'm going to go to x equals pi. And that gives you 5 key points through this cycle. Again, I reduced a couple of fractions down like that. Okay? Now we're going to number crunch. You're going to get away from all this number crunching in a little bit later as I teach this section. So what we're going to do is we're going to do the y equals sine of 2x. That's what we're graphing. So we're just going to plug in and calculate, and hopefully this will help you to understand how this period changes a little better. Okay? All right. So it goes like this. First thing we're going to do is we're just going to start with y equals sine of 2 times 0. And we're going to crunch these out one at a time. All right, I'm going to go ahead and just kind of get these set up. The next one we're going to do is the sine of 2 times pi over 4. You're just plugging, the x in. Then we go to y equals sine of 2 times pi over 2. And then we go to y equals sine of 2 times 3 pi over 4. And finally to y equals sine of 2 times pi. Okay? And what we're going to end up having on this is I want you to see what literally happens when you do this number crunching, because it'll always kind of be the same, right? So as we move through the next thing here, now we're going to just kind of crunch these things out. I want to write this out, kind of clearly and just kind of get a diagram. So we now have y equals sine of 0, y equals sine, and 2 pi over 4 reduces to pi over 2. And then the 2's cross out here to give y equals sine of pi. And then we get y equals, this is 6 pi over 4. So I'm just reducing these fractions. And then finally we get sine of 2 pi. So see, what I'm trying to show you is the increment's pi over 4, which is super important. So I'm just counting by pi over 4s on that unit circle, and I'm plugging into the function. And notice what happened is these things kind of go back to those standard every 90 degrees on a unit circle. So now we can just get these values on the unit circle. So if you look at 0, the sine of 0 is 0. The sine of pi over 2 is 1. The sine of pi is 0. And then the sine of 3 pi over 2 is -1. And the sine of 2 pi is 0. So what we have is we have our points now that we're going to have, and we're just going to graph this on our graph. I'm just going to kind of put this over like this. So we're going to further subdivide this by pi over 4. So what I want you to do is go to your graph and just kind of cut these intervals in half, and then we're going to go ahead and plot these key points that we just got. And I think you'll see kind of where I'm going with this, hopefully. So what we have is we have a point 0, 0. So I'm going to put that on there, use a different color. Then I've got pi over 4, 1. So go over pi over 4, up 1. That point goes there now. Then pi over 2, 0. And then 3 pi over 4, -1, which is down there. And then finally pi 0. So what we've done is we got 5 key points to cycle through this new period, and then just go ahead and connect that into a curve. So that's one period right there. Okay, so I wanted you to kind of see what happens when you find this increment and number crunch. You always divide that increment by 4 because technically there's really 4 spaces here. 1, 2, 3, 4. You're kind of finding a gap in between like that. 4 spaces gives 5 key points. Okay, so that's the idea with that. Pause if you need to pause. I'm going to move over a little bit to the side and finish this graph up now. You didn't have to write all this down, but it's kind of helpful if you can squeeze it in somewhere and at least kind of abbreviate that, or at least understand what I'm doing there. Because we're going to get away from having to write all that stuff out in a little bit here anyway. Okay, so what I'm going to do now is I'm just going to fill out, the chart. We had sine, that was 0. Let me just use that same color. Okay, when we went to pi over 2, we ended up having, on that, we ended up having 0. At pi, we had 0. So actually, if you filled out this chart, all those things would become 0, which wouldn't help you very much. So that's why we're going to learn how to do these problems without having to ever do that elementary function. We'll get to that point here in a minute. Okay, so just go ahead and complete this like this. Now you can predict where it goes. This goes now to its high point, then to the x-axis, then to its low point, like that. So that would be the second period. And that's good enough. You can graph over here if you want to. I'm not going to take the time to do that because it doesn't matter. So what I wanted to show you is that right there is 1 period. Okay, so the period is equal to pi. That's 1 cycle. And again, that cycle has 5 key points. Those 5 key points are 1, 2, 3, 4, 5. So that's how that happens. And what happens on that is that 2 caused the graph to shrink horizontally. That's the idea. Okay, we're going to look at some examples of each of these, and I'm going to let you probably do a couple of where you number crunch the same way I did here. And that's the only way I think to really understand what's going on. Then we'll get to some shortcuts where you won't have to do all this number crunching every time. But what I wanted to show you, and this is real important, is when we picked these numbers from the increment, all it did was it just made this go back to the basic graph, okay, going by 90 degrees. Okay, and that will always happen. And your key points for y are always going to be 0, 1, 0, -1, and 0. Okay, you always should, if you do your increment right, you always should get those same y values for your 5 key points. Okay, all right, let's go to the next page, and I'm going to go ahead and do the next one here. And we're going to start this one off pretty much the same way. I am going to do some number crunching on this. You probably won't have room to do that, so at least watch what I do, and then you should be okay. All right, we're going to go ahead on this one, and we're going to use the same values in our table. We're going to go 0, pi over 2, pi, 3 pi over 2, 2 pi. Then do your negatives like we've been doing. Okay, so we got that. And then we're going to go ahead and just graph that. Now, one thing that you want to notice on here, because this amplitude is 2, when the final graph we're going to do, the amplitude's 2, what would that tell you about your y-axis? Yeah, you want to go up to 2. So let's go like this. And be sure you're real careful about this. So we want to get that set up like this. And then let's go ahead and get this thing put together. So get everything labeled. Okay, get your negatives labeled. Like that. Okay, so we're just going to start these graphs this way always. Now, what we're doing is we're doing a cosine. So we're doing a cosine, so we're just going to graph the basic cosine. So in a unit circle, remember the cosine is what? Okay, it's the x value. So we're going to fill out our chart just getting these x values. So if I start at 0, the cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is -1, and so forth. Okay, so that gives you your cycle. When you go to the negatives, negative pi over 2 is here, so that's 0. Negative pi is there, so that's -1. and then it just goes 0 and back to 1 like that. So that would be 2 periods of your cosine wave. So let's go ahead and plot those points then, if you will. Remember, you're going up to 1 as your max. Not ready to change the amplitude yet. And see, you can do this real fast because once you learn how these points cycle between the max, min, and the x-axis, then it's pretty easy to get that put in. So I'm just going to use like a dashed line, and I'm going to label that is the graph of y equals cosine x. Okay? All right, so we're just kind of getting the basic graph taken care of first of all. All right, and we're going to number crunch on this the same way we did the previous problem as well. So the first thing I want to do is let's find the period. The period formula is 2 pi over absolute value of b. In this problem, b is equal to 1/2. And I'm going to write this like this. I just have 2 pi divided by 1/2. Therefore, that's 2 pi times 2. So it's 4 pi. Okay, so we have an amplitude of 2 and a period of 4 pi. And that's going to cause this graph to stretch horizontally since the period is getting bigger. Okay, the increment, we always take the period and we divide it by 4. So take the 4 pi, divide by 4. Your increment is going to be pi. Okay, and that's real important to me. That's the whole key, is to figure out what are the good values of x on this final graph. Okay, so we got that. So I've done the plotting, figured out the period, amplitude, and the increment. Then we've graphed our basic one. Now we're ready to number crunch. Okay, now this, you might not have room to write this, so if you want to write it on a separate piece of paper or something, you can, or you can just watch this if you want to. So we're going to count these things out. So we're going to start at 0, but we're going to count by pi. So we have x equals 1 pi, x equals 2 pi, x equals 3 pi, and then x equals 4 pi. And we're just going to use these to kind of number crunch and get our final graph just through one period. Right, so what we're going to do is we're going to actually plug in just to this part right here. So we're not going to worry about the -2 until the end. I kind of like to teach students to work inside out. So what we're going to do is we're going to do y equals cosine 1/2 times 0. Don't worry about the -2. Let's just get this part taken care of. Okay, then we're going to do y equals cosine 1/2 times pi, and so forth. Y equals cosine of 1/2 of 2 pi. Y equals cosine 1/2 of 3 pi. And then finally, we're going to look at y equals cosine of 1/2 of 4 pi. And I want you to notice what happens on this. And this should ultimately help you understand how this period change thing works anyway, right? So I'm going to slide this over the side here a little bit. Now what do we have? We have y equals cosine of 0. This is pi over 2. Okay, this is pi. 2's cross out. This is 3 pi over 2. And then finally we have 1/2 of 4 pi is cosine of 2 pi. Okay, and this is what I want you to see on this. This is really cool. So what happens is, because of the increments that I chose, notice these numbers here are now going by 90s. So they're going to give you those basic values on the unit circle. Okay, so if you look at your unit circle, cosine of 0 is 1, cosine of pi over 2 is 0, cosine of pi is -1, and then 3 pi over 2 back to 0, cosine of 2 pi is 1. So you end up with those fundamental y values. Those are the important y values, 1, 0, -1, 0, 1. Okay, like that. Okay, now here's what we're going to do on this then. Okay, we're just going to go to our graph, and I'm going to put this together like this. Okay, we're just going to plot these points right here. I'm going to highlight kind of what we have. 0, 1 is a point, pi 0, 2 pi -1, 3 pi 0, 4 pi 1. Those are your key points. Now some of these are out of range of the graph, but we'll be able to cycle through this just fine. So if we start at 0, x equals 0, we have, this is at 1. Now the other thing that we're going to do is we're going, because of the amplitude, when we have the negative 2 cosine 1/2 x, we're just going to multiply this value. And we're going to do this in our head. So 1 times negative 2 is negative 2. 0 times negative 2 is 0. Negative 1 times negative 2 is 2. 0 times 2 is 0. And 1 times negative 2 is negative 2. So those are the y values of your key points then. So what we'll do is we'll put these numbers together like this, and those are the final points that we'll plot to get our graph. And again, some of these things are going to be out of range, but we'll be able to cycle through this anyway. So let's plot 0, negative 2 on our graph. Let's plot pi 0 and 2 pi 2. That's half of a period right there. That graph is going to go like that. Now, the nice thing is you can predict what these points are going to be. So if you went to negative pi, you would be there. If you went to negative 2 pi, you would be there. Okay? You can always number crunch those out if you need to. So that's what the final graph ends up looking like, is like that. So what I want you to get settled in your mind is when I choose the proper increment, it just ends up giving you these values that go every 90 degrees. And ultimately, it just gives you the key points with the max, min, and the y-intercepts. Okay, then at the very end, you can multiply by that amplitude to get your amplitude change like that. Okay, now if you fill out the chart here, well, this is what we found. Let's just see what we know here. We know at negative 2 pi, that was at 2. At negative pi, that was 0. At 0, that was negative 2. At pi, that was 0. And at 2 pi, that was 2. Those are our key points on that final graph, because we have the max and mins, so that's what you're trying to do. Okay, so that's what you're trying to learn how to do with this, is how to number crunch this, and I'm going to let you do a couple of problems trying to repeat what I just did, and then we'll kind of get away from that. I'll start showing you some shortcuts on here, all right? So I'm going to just kind of move here, and as you go to the next problem, go ahead and on both of these problems, actually, that you're going to do, just start off with these values. And then try to do what I've done on those two problems. And then I'll let you check and see. But try to do it yourself. This one had a typo in it. You need to do y equals cosine x first, using these x values, and then do this. And again, what you want to do is try to do this number crunching, probably on a separate sheet of paper, or you may have room down here if you write real small to get that put together. And then your graph, you want to just get these points. I'm going to go ahead and just kind of do this with you, and then kind of talk through how you start this, because you want to get this done in a certain way. And the other thing I want to mention on this is your amplitude on this is 4. You can do that in your head. So that means you probably need to go like this. Just go up to 4 and then go to down to negative 4 like that. Okay, so what you need to do is fill out the cosine, graph the cosine. I have a unit circle you can look at. Figure out the new period by using the formula 2 pi over b. Take the increment, find the increment by doing the period over 4, like I did here. Then plug in those 5 points that you get from your increment. Start your increment with 0, and then do your number crunching to get that final thing put together. And then do the same thing on number 2. What I'm going to do is pause the video, and I'm going to go ahead and work it out so when you're ready to check, you can see if you have the same stuff that I have, okay? And really, when you get right down to it, it's number crunching and plotting points. It really is. Okay, so it takes a little bit of work to do it this way. But the good news is we're going to start doing this a lot faster than this. So just trying to get you to try to understand how these period changes is why we're doing this, crunching out the details. So anyway, here's what you want to check on this. You want to check that you have the amplitude of 4, a period of pi, and then the increment of pi over 4. All right, you want to make sure that your row for the cosine is like this. Double check your table for the cosine, so you'd have these values. Then you want to double check that you graphed the basic cosine okay. All right, that's the simple part that we've already learned. Then I want to kind of show you the key is once you get that increment, you count by pi over 4. So you have start with 0, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Now these things get reduced. Okay, so this is just one, again, I'm going to do it over here. 1 pi over 4, 2 pi over 4, 3 pi over 4, and then 4 pi over 4. And see, I went ahead and just reduced the fractions. You can just kind of do that in your head as you go. So what I did is we're going to use these 5 values from our increment and just plug them in to y equals cosine of 2x, and then do the 4 for the amplitude change at the end. So you're just doing cosine 2 times 0, cosine 2 times pi over 4, and so forth. When you reduce that, the thing that I'm really kind of wanting you to see on here is, see these numbers here, they just go back to the 90-degree increments, which forces you to get these special points, 1, 0, negative 1, 0, 1. And then finally, the amplitude's 4, so you just multiply this y value by 4. So 1 times 4 is 4, 4 times 0, 4 times negative 1, and so forth. And that gives you your values. So what we kind of do on this then is we plot the point 0, 4, so you should have plotted the point 0, 4. And then, let's see, when we get to pi over 4, yeah, and so I chopped that up into an increment. So when you get to pi over 4, that's 0. So here's pi over 4, 0. Then pi over 2, negative 4, and so forth. Okay, so that's how you should have crunched that one out. Now pause here if you need to. If you need to get anything written down or think about what we did or anything, do that, because I'm going to go ahead and slide down to the next page. So pause now if you need to. Okay, on the second one, you want to see if you did this right on this. Okay, so again, the things you want to check is, first of all, check your sine graph. Just make sure you have the right numbers here. Make sure you plotted your sine wave, okay, that's the red one. Okay, and then get that out of the way, and then what we're going to do is you want to make sure that you have the amplitude is the, A is negative 1 here, really. That's a negative 1. So the amplitude's 1. The period is 2 pi over b. B is 1/2. So I did 2 pi divided by 1/2. Divide fractions by multiplying by the reciprocal. 2 pi times 2 gives 4 pi. And then your increment is take that period 4 pi, divide it by 4, so you would get pi. Okay, so what we're doing is when we're crunch out our 5 key points, we're going to start at 0 and then just count by pi. 0, 1 pi, 2 pi, 3 pi, 4 pi. And then we're going to plug in just to the sine of 1/2 x. Don't worry about the negative. Just kind of ignore that for now. And then do 1/2 times 0, 1/2 times pi, and so forth. Just plug these numbers in. And what I want you to notice is when you do half of the angle that you have in your increment, you just end up with 0 pi over 2 pi, 3 pi over 2, and 2 pi. So that will guarantee to give you these special numbers here. Okay? And then what you do now is just multiply. Once you get these numbers, you multiply by negative 1. So you're doing negative 0, negative 1, negative 0, negative, negative 1, negative 0 to get those final values. And then it's just a matter of plotting the points. So 0, 0, that's this point right here. Okay, that's a key point. Pi negative 1 is here. 2 pi 0 is here. And then I just started going backwards. Instead of going that way, just cycle through. I mean, you got 3 points here. That's got to be a max. That's got to be a min. So our key points are really 1, 2, 3, 4, 5, like that. Okay, that's what you should have come up with. You don't really have to fill in these intermediate values right here. Just kind of the critical things that popped up. And then that's good enough. Okay? All right, so we're going to get away from this now, and we're going to kind of revisit some of these problems in a little bit different way now. So pause the video if you need to get this down and kind of absorb what we did here. And let's move on to example 3. Okay, so what we'll do with this example is we're going to do this just no table. We're going to get away from tables. Okay, tables are a good way to learn, but then ultimately you can get away from it then. Okay, so we're going to graph this thing, and I'm going to show you how to do this in 2 stages. So the first thing we're going to do is you're going to find the amplitude. So the amplitude, of course, is 3. Okay, since the amplitude's 3, then it makes a lot of sense on your graph to go ahead and make your y-axis go from -3 to 3, like that. Amplitude kind of helps you figure out the y-axis. The formula for the period is 2 pi over absolute value of b. B is 4, so you're going to have 2 pi over 4, and then that fraction reduces to pi over 2. So your period is pi over 2. Okay, so we got that so far. Now, the next thing that's super important is that you get this increment down. When you do the increment, what you always do is take the period and you divide it by 4. Okay, so the period's pi over 2. If you divide by 4, that's the same as multiplying by a 4th. Okay, so that would give you pi over 8. And that's super important because that's going to tell you how you make your x-axis. Okay? Now again, what we're going to do on this, we're going to try to get away from making any tables so that we can do these graphs quickly and efficiently. Okay? So what we're going to do is we're going to count by the increment, starting at 0. So we just go 0, 1 pi over 8, 2 pi over 8. See, notice I'm counting by the numerator. 3 pi over 8, 4 pi over 8. And you can stop there because that gives you 5 key numbers. So we have 0, pi over 8, pi over 4, 3 pi over 8, and then pi over 2. So that's going to tell us how to make this x-axis. So we're going to go ahead and now we're going to do this like this. We're just going to say, okay, that's pi over 8. This is pi over 4. This is 3 pi over 8. And that's pi over 2. And that's going to take us through one cycle. All right, now I'm going to go ahead and do the negatives, but a lot of times I just have your graph one period. So I'm going to go ahead and do that. Because if you can get one period done, then it's easy to get the other one. And you can graph as many periods as you want to. Okay, so that's kind of the key in the problem, is to find the amplitude period and increment, count out the increment to get how to figure out the x-axis. Okay, now what we're going to do is we're going to do 2 stages on here. Stage 1 is just do y equals sine of 4x. Okay, I'm going to teach you kind of a shortcut on there. Kind of what we like to do is work inside out. Do this part, and then stage 2, we will do y equals 3 times sine of 4x. Okay, so let me show you how this goes ultimately. All right, so the idea is if you can just remember how the sine goes, the sine of 0 is 0. So what we're going to do is we're going to do this. We're just going to start the graph here, and then we're going to go to the maximum value. Now, instead of going to pi over 2, the sine of pi over 2 is 1. Well, the period changed, so we use pi over 8, but it still has the same y value. Okay, then we go to the next one where the sine is 0, but instead of having pi, we have pi over 4 because the period changed. And then the same thing here, and see, now you can kind of get that graph done real quickly like this and efficiently. So the red graph is going to be the graph of y equals sine of 4x. See, all you've got to do is just really look at these values. Those are your key values. They always are. But the increment told you where those key values are. And then you can just pencil in the cycle like this, and then we've got a graph through 2 periods like that. So that's the idea. Okay, now the next thing is stage 2. All we're going to do is multiply the y values in stage 1 by 3. And you're just going to do this in your head on your graph. So it's actually very simple to do this. Okay, so this point right here has a y value of 0. So 3 times 0 is 0, so that point goes there. Okay, the next point has a y value of 1. So 3 times 1 is 3. That point stretches vertically to that point. The next y value is 0, so we have 3 times 0 is 0 again, so that stays. Then we have negative 1, so 3 times negative 1 is negative 3. So it goes like that. And once you get a few points, you can predict where the rest of them go. So it's going to cycle through y values of 0, 1, 0, negative 1, 0. Right here would be one period on your graph. Now we are done. See, no table or anything required. And then you can move on and then just do the other period, just going through those same cycle of points like that. And there's your graph. It's 100% accurate when you do that then. Okay? All right, now, so you want to be able to do these things by hand, too. I'm going to, a little bit later, show you how you can do some of this on your graphing calculator, but I'm not interested in that at this stage. So that's the answer to the problem. And here's one other thing that's worth showing you all, is that you can check your points. And you can check as many as you want to. So these problems are 100% verifiable. So what I'm going to do is I'm just going to, pick a few points and see if they work. Let's just pick these 2 points and check these 2. Okay. What I'm going to do is I'm just going to plug those in to the graph we're doing and just do it all at once. Okay. So we got 3 sine of 4 times 0. Just plug the 0 in. Well, that's 3 sine 0. The sine of 0 is 0. So we get 0. So that means we have a point 0, 0. And we clearly have that point 0 right there. Okay, try pi over 8. So we'll do y equals 3 sine of 4 times pi over 8. Okay, that gives 3 sine of pi over 2. The sine of pi over 2 is 1. 3 times 1 is 3. So that means when x is pi over 8, y is 3. Well, that's clearly what we got on our graph. So you can plug your points in and see if they're right. And the nice thing about it is, when you transform these points, they should always end up having those special values of 0, 1, negative 1 on the unit circle. That's kind of the way that you want to get to graphing these, is like that. That's going to simplify that process now. Okay? All right, so let's move on to the next thing here. We're going to get away mostly from tables of values now for a bit. So I want to talk about one other thing. We have the vertical translation, and these are things you learn a lot about in college algebra. So we're kind of expanding on this function. So if you have y equals a sine of x, and you don't need to write this down, I just want to show you the piece that we're adding here. Remember, absolute value of a is the amplitude. Okay, if you do the period is 2 pi over absolute value of b, and then the c is either up or down, and what that does is it adds to the y values. Okay, and when you do the more complicated trig functions, you kind of do it like this. You start there, you worry about a period change first, then you add in the amplitude change, and then the third thing you do is you do that. So there's kind of an order that you transform things in. So again, what we're going to try to do on these problems is try to do this in just a few steps, okay, and no table of values, and try to get out of that. Okay, so I think this one, I didn't type this right, so the function that we're going to be working with is this right here, okay? All right, so let's just do as much as we can in our head. What's the amplitude? Amplitude's 1/2. What does that tell you? That tells you that the max is 1/2 and the min's negative 1/2, but we now have this up to thing that we got to consider, okay? Now let's go to the period. Okay, the period is 2 pi over b. What's b? b is pi. It's the number in front of x. So we're going to have 2 pi over pi. The pi's are going to cross out, leaving you 2. And it's okay if the period's just a number. It doesn't have to have a pi in it. So far we have amplitude and period. Those things have both changed. Okay, the increment, what do you do on the increment? You take the period and you divide it by 4. So we take 2 over 4 to get 1/2. Okay, so the increment's real important because that will tell you how to do the y-axis. Okay, and then the next thing is the vertical translation, which is this number right here. So that 2 is taking you up 2 because it's positive. So we say up 2. Then I'll explain the midline here in just a few minutes. Let's go ahead and get our graph set up, and I'll show you the stages that we're going to do this in then. Okay, so I would go ahead and get your increments. So just start counting, start at 0, and count by 1/2. So you have 1 over 2, 2 over 2, 3 over 2, 4 over 2. So your key points on the x-axis are 0, 1/2, 1, 3/2, and 2. That's the end of the period. The period's 2, so you've got 1, 2, 3, 4, 5 key points. So we're going to label this like this. This is 1/2. This is 1. This is going to be 3 over 2, and that's going to be 2. Period change changes the key values on the x-axis. Let's go ahead and do the negatives. Okay, like that. Now, we've got to think a little bit about this. Now, the amplitude is going to kind of smash things down so that the max is 1/2, min's negative 1/2, but you're adding 2 to it. So you have to add 2 to 1/2 to get the maximum. So the maximum is going to be at 2 1/2. So what I'm going to do is just say that's 1, that's 2, right there is 2 1/2. And then down below we're going to say that's negative 1, that's negative 2, that's negative 2 1/2, like that. Okay, so you got to think about how that up translation figures into this. Okay, we're going to do this in a couple of stages. You can learn to do this in 2 stages. That's what I want to ultimately kind of get everybody down to doing then. Okay, so stage 1 is we're just going to do y equals cosine of pi x. We're going to work inside out, and we're only going to focus on this. And here's how it goes. Okay, so what you have is the starting point on a cosine is 0, 1. Right? Again, you can look at a unit circle. I'm going to copy and paste this unit circle and kind of show you what my thought process is here. So the idea is when you're at 0, then the cosine of 0 is 1. Okay, so for now, what we're going to do is we're going to do this. We're just going to plot the main cosine values. The main cosine values go 1, 0, negative 1, 0. Okay, and again, we've got the increment change, so we just put a dot there. Then we put a dot here, and then down to the minimum, like that. That is actually the graph of, and it's good to label this, that's the graph of y equals cosine of pi x. Okay, so that's what that is, right? And then we can go ahead and just move on, you know, and do another period of this if you want to. So it goes like that. Now see, what we've changed is we haven't changed the key y values. We've changed the x values for where they lie. So that's the idea. That's step 1. Now the second step is we're going to do this. Since we're working with y equals 1/2 cosine pi x plus 2, all you're going to do is look at these numbers right here, and you can do this all in your head. You really can. So what we're going to do is we're going to multiply y by 1/2, then add 2. Okay, so just take these key values on your original graph here. So I'm going to start here with this y value of 1. So we just do 1/2 times 1 plus 2. That gives 2 1/2. Okay, so that's where that point goes, is that point moves all the way up to 2 1/2. That's your first point. Okay, go to the next y value. The next y value is 0. So we go 1/2 times 0 plus 2. So that's equal to 2. So that value moves there. Okay, Next y value is -1. So we go 1/2 times -1 plus 2. That's 2 minus 1/2, so that's 1.5 or 1.5. So that means this point, this third point, has a y value of 1.5, so it's there. Okay, and then we got 2 more to go. Back to the y value of 0. We've already done that. 1/2 times 0 plus 2 is back to 2. So this point moves here, and you can predict that the next one's going up to 2.5. So now what we do is we do 1/2 times this y value of 1 plus 2, so that gives 2.5. Okay, so that's where your points come from. So again, let me just, if you're confused about what I'm doing, the increment is what I'm doing. Okay, so I got my increment, that's where the key points go. Then I'm taking these y values on the unit circle. Okay, so I've got the, I've got the 1, I've got the 1. Cosine, I've got the 0, -1, 0, and back to 1. Those are the key y values that you get, and I crunch it out. So what you'd end up having, your graph would look like that through one period. Okay, and you can scroll down, do the rest. You can move over and just kind of see where the points go now, because it's symmetrical. So then the second period would go like that if you want to do that. So that's how that goes. All right, now what the midline is just a point that goes through what we call the midpoints. The midpoints are halfway between the max and min. So a midline on this would go like this. I'm just going to use maybe a color kind of like this. So the midline would go like that. And that midline would be y equals 2. Okay, so it's just a line that cuts through the midpoint of the graph, halfway between max and min. Okay, that's the answer to the problem. Okay, and you can always check by plugging points in. All right, so I'm going to run through another, have you try to do a problem here and just kind of see what you can do. Again, what you need to do is first figure out you want to get these things figured out. Figure out amplitude, period, increment, vertical translation, and then go through and graph. You want to graph the basic sine. So you want to do this in 2 stages. You want to do y equals sine of 2 pi x, just that part right there. Just do that only. Then add in the other things. So add in the -2 times the y values minus 3 to get your final product. Give it your best shot. See how it goes. And then I'll come check on you here in just a minute. But please pause and please try. It's the only way to learn this. Okay, so I'm going to let you check this and see if you did this okay. And I'll kind of talk through this okay. So let's see. First thing is amplitude. Amplitude is the absolute value of that number, so that's 2. The period is 2 pi over this number, so 2 pi over 2 pi will give you 1. Okay, can't mess up on the period because that'll mess up the increment and it'll mess the whole thing up. The increment, you take that period and divide it by 4, so it's 1/4, right? So when you counted the increment, you should have counted by 1/4. So 0, 1/4, 2/4, 3/4, 4/4. Reduce the fractions. Those 2 fractions reduce, and then this would be how you would do your x-axis. So you'd have 1/4, 1/2, 3/4, 1, and then the negatives in the same way. Okay? All right. And then the vertical translation is, this time that's a -3, so it makes you go down 3. Okay, so here's what you do in 2 stages. You do your graph this way. And again, what you got to remember on a sine, starting with 0, the sine has these key y values. Okay, so what I did is I graphed 0, 0, and then max of 1, min, whoa, did I get off track there? Oh my, I think I did this okay, but I may have done my graph. I kind of messed my graph up there a little bit, it looks like. So I kind of got off track. Shoot. I don't know what's wrong with me. Gosh. I think I just missed that 1 point, though. So this would be 0, 1, 1/2, then you'd be at 0, and then down to there, and then like that. Okay, gosh. Okay, so we have the graph that goes like that. So again, it would be 0, 0, then the next key point has a max of 1, back to the x-axis, then the min, like that. And we're mostly interested in the final points like that. So again, you got to understand that in a sine, if you look at your unit circle, just look at this unit circle right here and look at how these y values go. The y values starting at 0 go 0, 1, 0, -1, 0 over and over again. That's why I did that. Okay. Now to get your final product, what you do is, since you have -2 sine 2 pi x minus 3, you're going to take these y values in that graph, which are 0, 1, 0, -1, 0, multiply by -2 and subtract 3. So that's what I did here to get the final points on the graph. So -2 times 0 minus 3 is -3. So I plot the point 0, -3. So that is your first point right there. That's point number 1. Point number 2, you do -2 times 1 minus 3. So you get the point right here. You get the point 1/4 and then -5. So you go over 1/4 and then down 5. That gets you your second key point and so forth. And then from here, just keep crunching them out. The graph would go back to -3. Then it would have a y value of -1 and so forth, like that. So see, what you're doing is you're taking these y values on your basic graph, on the graph of sine 2 pi x, and then you're multiplying by -2 and subtracting 3. That's how those points get converted. Okay, then the midline is just the line that goes through the midpoint of the graph. So that would be going down -3. So that midpoint's -3. Okay. Now I want to mention this is it's always a good idea, like if you're doing an exam or something like that, to check a couple of points. So you really should check a couple of things. So I'm going to just check these points right here. I'm going to check x equals 0. And then I'm going to check x equals 1/4. Okay, just the first two things on this increment, 0 and 1/4. And plug into the whole freaking thing. Okay, go y equals -2 sine 2 pi times 0 minus 3. Plug into this whole function. Then you have y equals -2 sine 2 pi times 1/4 minus 3, and see if it matches what you ended up getting. If the first 2 points are okay, then you're probably fine. So this would just be -2 sine 0 minus 3. So that would end up being, remember the sine of 0 is 0, so that would be -2 times 0 minus 3, so that's -3. Okay, and that matches that point. So when x is 0, y is -3. So that's on your graph. Do the same thing with 1/4. You would have y, -2 sine, and then 2 over 4 reduces to pi over 2 minus 3. Well, the sine of pi over 2 is 1. -2 minus 3 is -5. So notice that when x is 1/4, you have -5. So plug in a couple of points in your increment and see if they work, and then you're probably okay. Right? Because that's ultimately what you're doing anyway. Okay, there's a little bit of a learning curve to this, and but once you catch on to it, it's not that hard to do. Okay, I want you to do one more thing, and then that'll close off this part of the lesson. So I want you to go ahead on these two problems and just fill them out. You're not going to graph those, just fill these out and then come back and check, and then that'll conclude the second part of this lesson. Okay, so let's see how we did. Figuring out the minimum and maximum of y may have been a little confusing for you, so I'll show you how you do that. But on the first one, the amplitude is the absolute value of -6, so that's 6. That's the easiest part. The period is 2 pi over b. b is 3, so 2 pi over 3 would be the period. The increment, you take the period divided by 4. So 2 pi over 3 divided by 4 is really 2 pi over 3 times 1/4. That's 2 pi over 12. That fraction reduces to pi over 6. Okay? So that's what you should get on that. Now let me show you how you do this. Okay, on the minimum of y and the max of y, all you really look at is this part right here. Don't pay attention to the -5 yet. Okay, if your amplitude is 6, that means originally you would have a max of 6 and a minimum of -1. But we're taking everything down 5. So if we take the max down 5, that'll give a new max of 1. If we take the original min down 5, that'll give -11. Now, one thing I want you to notice on this is the distance between -11 and 1 is 12. The way you find the distance between two numbers is you subtract them. So the distance between these numbers is 12. Remember, the amplitude is half of that distance. So you can tell you've done that right. Look at the distance between the min and max and see if the amplitude's half of that. Then you know you've done that right. Okay, that'll help. Okay, the next one, the amplitude's 1. There's nothing in front of the sign. The period is 2 pi over b. b is pi over 4. So 2 pi, you'd have to divide by pi over 4, which means multiply by the reciprocal. So you'd have 2 pi times 4 over pi, which would give 8. Okay, the increment is the period 8 divided by 4, so 8 divided by 4 is 2. Okay, and then again on the max and min, it goes like this. Okay, so just look at sine pi over 4x only. Don't pay any attention to the 1 yet. If your amplitude's 1, that means you would have a max of 1, and it means you would have a min of -1. However, you're going up 1, so add 1 to the max to get a new max of 2. Add 1 to the min of -1 to get a new min of 0. So that's how you do that. Okay, so that'll wrap this second part up. When you start getting into a period change, it starts getting a little bit more complicated. But with practice, you'll get it down. This stuff takes a lot of practice, but you'll get to a point where you can do your graphs fairly well, I think. Okay, so that will wrap this part up. So I'll post this, and then we'll do a couple other parts of this.